Hello children, in this session let us discuss about formulae or chemical formulae. Okay, so you know that any language consists of three things, or it is made up of three things. So what are those? Alphabets. Then these alphabets combine to form words, and these words combine to form sentences. Similarly, in our language of chemistry, we have all these three steps. The first step, alphabets, is nothing but symbols of the elements. We have discussed already. So, symbols of elements, which we have discussed already. So, these symbols combine to form words. These symbols combine to form words. These words are nothing but chemical formula, chemical formulae. Okay, and these will form chemical reactions. Now we have already discussed about the alphabets. Now we have to frame words. So how do you frame words? You need some phonics, right? So similarly, for writing the chemical formula, you have some conditions. There are some necessary conditions. That means we need some information. We need some information to write the chemical formulae from the symbols. So what are the two conditions? Means those are nothing but symbol of the element or the radical. Symbol of element or radical. The second thing is you need valency of the element or radical. Valence of the element or radical from which the molecule is made up of. Okay, so formulae. So what is meant by formulae? We will discuss that, and then we will discuss about all these necessary conditions. Okay. So what is formulae? It is nothing but symbolic representation of a compound. Okay, symbolic representation of a molecule simply. Okay, so symbolic representation of a molecule is nothing but formulae or molecular formulae. Symbolic representation of a molecule. So it is known as formula or molecular formula. So if you have a molecule, for suppose if you take water molecule, so how do you write water molecule? Every time you cannot write water wherever necessary. So instead, in the chemical reactions, what you will do, you will write its molecular formula. So what is its molecular formula? What is the symbolic representation of water? So symbolic representation of water is nothing but H2O. So what is the symbolic representation of hydrogen? You know that water consists of hydrogen and oxygen. So the symbol for hydrogen element is H and the symbol for oxygen is O. Okay, so the valence of hydrogen is 1 and the oxygen is 2. So we will get a symbolic representation. We will get a formula as H2O. Like how to write this formula we will discuss later. First you understand the definition of formula. Okay, so what is formula? It is nothing but the symbolic representation of a molecule. So if you have any molecule, O2, H2, N2, any molecule if you take, so the symbolic representation of it. So instead of writing oxygen molecule, nitrogen molecule, hydrogen molecule, you can represent it by writing its symbol. That is nothing but O2, N2, H2, F2, H2O, SO2, SO3, like that. You can mention it by writing the symbols, right? So, Nandamuri Tarak Ramarao, instead of writing like that, we will write NTR. Okay, similarly, the symbolic representation of any molecule is known as formula or molecular formula. This molecular formula is also known as chemical formula. Okay, so formula, molecular formula and chemical formula, all are the same. Okay, so what is it? It is nothing but symbolic representation of a molecule. So this molecule, symbolic representation of a molecule gives us the number of atoms of each element. The number of atoms of each element present in the molecule. So let us consider water molecule. So how many elements are there? Hydrogen and oxygen. So what is the symbolic representation of water? H2O. H2O. So elements are hydrogen and oxygen. Hydrogen and oxygen. So how many atoms of hydrogen are there in one molecule of water? So 2 hydrogen atoms are there. And how many oxygen atoms are there? 1 oxygen atom is there in one molecule of H2O. Similarly, if you consider SO2, sulfur dioxide. Okay. So how many elements are present in sulfur dioxide? 2 elements are there. So sulfur, oxygen. How many sulfur atoms are there? 1. How many oxygen atoms are there? 2. Okay. So this molecular formula, symbolic representation of a molecule, gives us the information about number of atoms of each element present in one molecule of the given molecule. Okay. So now if you take SO2, it consists of 1 atom of sulfur and 2 atoms of oxygen. One molecule of sulfur dioxide consists of 1 atom of sulfur and 2 atoms of oxygen. Similarly, one molecule of H2O consists of 2 atoms of hydrogen and 1 atom of oxygen. Clear? So you can take any examples. Carbon dioxide. So if you take carbon dioxide, so how many atoms of carbon are there? 1. How many atoms of oxygen are there? 2. So it gives us the information of the number of atoms of each element. So what are the elements? Carbon and oxygen. So how many carbon atoms are there? 1 carbon atom. And how many oxygens are there? 2 oxygens. So it gives us the information about the atoms, the number of atoms of each element present in the molecule. So molecular formula or chemical formula or simply formula is nothing but the symbolic representation of the molecule. Symbolic representation of the molecule, and it gives us the information about number of atoms of each element in the compound, in the molecule. Number of atoms of each element in the molecule. Okay, so now let us see how to write this molecular formula. How to write this molecular formula. So to write any chemical formulae, we need this information. So the first one is, you should know the symbol of the elements or the radicals which is present in the molecule. Okay, so you also have to know about the valency of, if it is an element, valency of the element should be known. If it is a radical, the valency of the radical should be known. Okay, so the method of writing this chemical formulae is known as criss-cross method. Criss-cross method. Okay, so there are several steps involved in this criss-cross method. Let us see one by one. Okay, so we need 2 things: symbol and valency. Symbol and its combining capacity. It may be element or radical. Okay. So let us see now how to write. So the first step is, you have to write, for example, if you take magnesium chloride. So this is a molecule. Magnesium chloride is a molecule. So what is its symbolic representation? How do you represent it? By using the chemical formula. That we will discuss now. The first step is, you have to write the symbols of each element present in that. So what are the elements present in that? Magnesium and chlorine. Okay, so you have to write the symbols of the elements present in a molecule side by side. Side by side. This is the first step. Okay, so what is the symbol of magnesium? It is Mg. What is the symbol of chlorine? Cl. So writing side by side is okay. So which one should be written first? So you have to write the basic radical first. Basic radical is nothing but electropositive radical, which is nothing but cation. This is nothing but cation. This should be written first, and then you have to write the acidic radical or electronegative radical or the anion. Okay, so you have to write the symbols of the elements present in the given molecule side by side, in which basic radical should be written first and then acidic radical should be written. This is the first step. So what is the second step? So after writing the symbol side by side, you have to write their oxidation states. Those are nothing but valencies. You have to write their valencies. So magnesium has the valency 2, chlorine has the valency -1. Okay. So magnesium 2, chlorine 1. You forget about the charges, Mg2 plus and Cl -1. So you forget about the charges. You ignore the charges. You write only the valencies. So Mg valence is 2, chlorine valence is 1. Okay. Now for magnesium chloride you don't have any problem. But if it is calcium oxide, consider if it is calcium oxide. So first step is you have to write the symbols side by side. So basic radical should be written first. So what is the basic radical? That is nothing but calcium. So calcium. And then oxygen. Next you have to write the valencies on the top. So calcium 2, oxygen 2. If you have the common numbers like this. So here 2, 1. Valencies are 2 and 1. So no problem. Here you have 2 and 2. So you have common factor. That means you have common valency. So if you have common valency, in these cases, what you have to do? You have to divide it with highest common factor. Highest common factor. Here you don't have any problem. So you have the common factor is 2. So you can divide it by 2. So divided by 2, divided by 2. So what is the valency of calcium? 2. Valency of oxygen? 2. So 2 ones are 2 ones are. So here you will get calcium 1, oxygen 1. Okay. So if you take the elements with valencies 2 and 4. 2 and 4. Here, you know 2 2s are 4. 4 is divisible by 2. So here you have to divide it with the highest common factor. So what is the highest common factor among 2 and 4? So 4 is the highest common factor. Right? So how do you do this now? So if you divide it, what happens? You will get here 2 1s are, 2 2s are. So I mean this element will have the valency 1 and the second element will have the valency 2. Okay, so for example, if A2B4, A2B4. Okay, so now you have to divide it with the highest common factor. So what is the highest common factor here? 2. It is 2. Okay, so common factor means here 4. You cannot take the 4 as a common factor because here you don't find any 4. Here you find 2 and here you can find it as 2 square. Right? So 2 2s are 4 but not 4 2s are 2. Okay. So here you cannot take 4 as a common factor. You can take 2 as a common factor because A consists of 2 valency and B consists of 2 2s are valencies. So you can take 2 as the highest common factor. Common factor means it should present in both A and B. Okay. So now if you divide it with the 2. So what happens? So 2 1s are 2 and 2 2s are 4. So B 2. Okay. So what happens now? A1, B2. Understood? So first step is write the symbols side by side. Next step is write their valencies on the top. Third step is you have to divide it with their highest common factor. Highest common factor. Okay. So after dividing you with highest common factor, what is the highest common factor here? It is nothing but 1. So you will get Mg2 and Cl 1 again the same. Okay. So what is the fourth step? You crisscross them. That means you write these valencies to the opposite radical at the lower end. For example, if you take magnesium and chlorine. So magnesium valency is a 2. So you write it here. So if you write, what happens? Mg will have the suffix as 1 and chlorine will have the suffix as 2. So here in this case, Ca will have the suffix 1 and oxygen will have the suffix 1. Now you join them. So if you join them, what happens? So MgCl2. MgCl2. So here it is CaO. So here what happens? A, valency of B is 2. So you write it here. B, valency of A is 1. So you write it here. So A to B1. That is nothing but A to B. Okay, 1 means you can ignore that. You no need to write 1 as a suffix. Okay, so A to B. So here magnesium chloride. So what is the formula for magnesium chloride? MgCl2. So here this is in the case of simple radicals. If there are compound radicals, then what you will do there? So let us discuss. Let us take hydroxide. For suppose aluminium hydroxides. Aluminium hydroxide. Now you have to write the chemical formula for aluminium hydroxide. Aluminium hydroxide. Okay. So what is the first step? You have to write the symbols. You have to write the symbols of the elements or the symbols of the radicals present in the molecule. So what are the symbols of the elements or radicals present in aluminium hydroxide? Those are aluminium hydroxide means OH. You know the symbol for hydroxide is OH. Okay. So if you don't know the valency of these compound radicals, you can calculate it easily. So oxygen, you know the valency is 2 minus hydrogen H plus 1. So minus 2 plus 1, you will get minus 1. So the valency of OH is minus 1. Hydroxide ion is, oxidation state of my hydroxide ion is minus 1. Okay. So the first step is you have to write the symbols side by side. So what is the second step? You have to write the valencies on the top. Okay. So what is the valency of aluminium? It is 3 plus hydroxide is OH minus 1. Minus means minus 1. I told you, you have to ignore the charges. Positive or negative charges, you can ignore them. So aluminium 3, hydroxide 1. So what is the next step? You have to divide it with the highest common factor. So what is the highest common factor for 1 and 3? It is 1. So 1 does not consist of 3, but 3 consists of 1. 3 ones are 3. Okay, so 1 ones are 1. So what is the highest common factor? It is 1. So if you divide it with 1, what happens? You will get the valency of aluminium as 3 and the valency of hydroxide as 1. So there will be no change. Okay, so now let us crisscross them. So if you crisscross, the next step is you have to crisscross. So you have to write the valencies here. So if you write, what happens? Aluminium 1, hydroxide. Now here the problem arises. So here it is a simple radical chlorine. So you have written it as 2 as a suffix easily. But if you write 2 here, so what happens to this means 1 atom of oxygen and 2 atoms of hydrogen, which means it is wrong. So in case of compound radicals, you have to use a small bracket. So you have to use a small bracket. Okay. So OH taken twice or simply OH twice. Here it is not twice. What is the valency of aluminium? It is a 3. So here you will write it as 3. So you join them together. You ignore this one valence 1. Then what will be the formula for aluminium hydroxide? AlOH thrice. This is the chemical formula for aluminium hydroxide. Chemical formula for aluminium hydroxide. Okay, so let us see some more examples. So if you take calcium sulfate, now you have to write the formula, chemical formula or molecular formula for calcium sulfate. Okay, so how do you write? First step is you have to write the symbol of the elements or symbols of the radicals. Okay, so what is the symbol for calcium? C. What is the symbol for the radical sulfate? Radical sulfate is a compound radical. So sulfate symbol is SO4. 2 minus. Okay. So now the second step is you have to write their valencies. So Ca 2 plus, SO4 2 minus. I told you to ignore the positive and negative charges. So now if you ignore these charges, Ca2, SO4 2. So this is a compound radical which is made up of group of atoms, that is 1 sulfur and 4 oxygen atoms. Okay, so here it is a simple radical which is made up of only one atom, that is calcium. Clear in this. So after writing this, what you have to do? You have to divide the valences of the elements or radicals with highest common factor. So 2, 2. So which is the highest common factor here? It is nothing but 2. So if you divide 2 with 2, you will get 1. If you divide 2 with 2, you will get 1. So now what are the valences after dividing with highest common factor? So Ca 1, SO4 1. Now you crisscross them. So if you crisscross, what happens? Ca1, SO4 whole 1. But since here it is 1, you can ignore that. So no need to write this brackets. Now you can remove all these ones and brackets and you can write the formula as CaSO4. So what is the formula for calcium sulfate? It is CaSO4. Okay. So calcium sulfate. Valence of calcium is 2. Valence of sulfate is 2. So if you divide it with highest common factor, you will get Ca1, SO4 1. So if you crisscross, you will get CaSO4. Clear? Now let us see one more compound. That is ammonium carbonate. So ammonium carbonate. Okay. So while writing the symbols of ammonium, you should be careful. If you write it as ammonia in NH3, it is nothing but symbol for, it is a molecule of ammonia. But if you want to write about ammonium, it is NH4 plus. This is the symbol for ammonium ion, NH4 plus. Okay. So now let us see how to write the chemical formulae for ammonium carbonate. So what is the first step? You have to write the symbols of the elements or radicals. So here we have ammonium radical and carbonate radical. Ammonium radical is also a compound radical and carbonate radical is also a compound radical because they are made up of group of atoms. Okay, so what are the symbols for ammonium and carbonate? For ammonium it is NH4 and carbonate it is CO3. Ammonium NH4 and carbonate CO3. Now, if you don't know the valences of this, second step is you have to write the valences. So, if you don't know the valences of this compound radicals, so how do you calculate? So, you know the valency of nitrogen is 3 minus 3 and hydrogen is plus 1. Hydrogen is plus 1. So, how many hydrogens are there? 4 hydrogens are there. So 4 hydrogens means plus 1 into 4, that is equals to plus 4. So plus 4 minus 3, that will be equals to 1. Plus 1. So what is the valency of ammonium here? It is plus 1. Similarly for carbon. carbonate. So carbon it is 4, oxygen it is -2. So how many oxygen atoms are there? 3 oxygen atoms are there. So 3O -2 into 3, that is equals to -6. So -6 plus 4, that is equals to -2. So what is the valency of this carbonate ion? That is -2. So what will be the valencies now? I told you to ignore the charges on this. So if you ignore the plus and minus charges, the valency of ammonium will be 1 and the valency of carbonate will be 2. Clear? Now what we have to do? We have to divide it with highest common factor. So what is the highest common factor for 1 and 2? It is nothing but 1. So if you divide with 1 with 1, you will get 1. If you divide 2 with 1, you will get 2. Okay. So now you have to crisscross this. 1 should be written here and 2 should be written here. So NH4, I told you, if it is a group of radical and if you are representing any suffix to it, you have to use a small bracket for that. So NH4, 2. That means this 2 belongs to both nitrogen and 4 atoms of hydrogen. That can be represented like this. So NH4 twice, NH4 taken twice, CO3, 1. So you can write it as CO3. So what is the formula for ammonium carbonate? NH4 twice, CO3. NH4 twice, CO3. So this is how to write the chemical formulae for the given molecule. Okay. So it is nothing but the symbolic representation of the molecule. So by using this crisscross method and by following the steps in the crisscross method, you can write the chemical formula for any molecule. So in the next class, we will discuss about naming certain compounds, how to name some compounds, that we will discuss in the